Hi students, welcome to physics classes. Today we'll discuss very important topic, parallelogram law of vectors. Now here two vector quantities can be added using parallelogram law. This law is useful to find both magnitude and direction. Now two vectors p bar and q bar are represented sides of a parallelogram, adjacent sides of a parallelogram, their magnitudes and directions. P bar vector magnitude and direction, q bar vector magnitude and direction are represented adjacent sides of a parallelogram. Their resultant represents diagonal of the parallelogram R. Both magnitude and direction. Resultant magnitude and direction is represented as a diagonal of parallelogram. P bar, Q bar, two vectors, their magnitudes and direction represented two adjacent sides of a parallelogram. Theta is the angle between them. P bar vector is AB, Q bar vector is AD. Their resultant magnitude and direction is represented with the diagonal of the parallelogram. Now we can form a parallelogram like this. See, AB one vector, AD another vector, AC their resultant. Now here BC is equal to AD, that is equal to Q bar. So here we can write Q bar, parallel, no? So now we can extend AB and we can draw one perpendicular at C. It forms like a right angle triangle. Name we can keep E. Name we can keep here E. Now the angle between P vector and Q vector is theta. So here also angle is theta. Now from the triangle CBE, angle at CBE is equal to theta. Now here we can take triangle CBE. In this triangle, cos theta equal to adjacent side BE by hypotenuse BC. Sin theta equal to opposite side EC divided by BC. As we know, BC is equal to Q, BE equal to, coming this side, Q cos theta, EC equal to Q sin theta. Now from the right angle triangle ACE, triangle ACE, from Pythagoras theorem can we write AC square equal to AE square plus EC square, AE square plus EC square. Now AC square we can write R square equal to AE square. From A to E we can write AB plus BE whole square plus EC square. Now AB square AB plus BE whole square, we can write it is AB square plus BE square plus 2AB BE plus EC square. AB square we know that is equal to P square. BE square Q square cos square theta. Q square cos square theta plus 2 into AB means P, BE means Q cos theta plus EC square, EC Q sin theta, Q square sin square theta. P square plus Q square cos square theta plus 2PQ cos theta plus Q square sin square theta. R square equal to P square plus Q square cos square theta plus 2PQ cos theta plus Q square sin square theta. Now R square equal to P square plus Q square cos square theta, Q square sin square theta. I am taking Q square common, cos square theta plus sin square theta plus 2PQ cos theta. Next P square plus Q square, we know cos square theta plus sin square theta equal to 1 plus 2PQ cos theta. R square equal to, then R equal to square root of P square plus Q square plus 2PQ cos theta. This is the magnitude of two vectors. Magnitude of two vectors. Now the magnitude R equal to P square, square root of P square plus Q square plus 2PQ cos theta. Theta is the angle between two vectors. Theta is the angle between two vectors. Now direction. Direction of the resultant. Direction. Now resultant vector, let us take resultant vector is making an angle alpha with P vector, making an angle alpha with P vector, okay, P bar. Now from the triangle CAE, from the triangle CAE, tan alpha equal to tan opposite side EC by adjacent side AE. We can write it EC divided by AB plus BE. B for boy, BE. Now EC we already know Q sin theta, Q sin theta by AB P plus BE Q cos theta. Tan alpha equal to Q sin theta by P plus Q cos theta, or we can write alpha equal to tan inverse Q sin theta by P plus Q cos theta. This is the direction. This is the direction. Now resultant equal to R equal to magnitude P square plus Q square plus 2PQ cos theta. Alpha equal to tan inverse Q sin theta by P plus Q cos theta. Now we will see some special cases. If P bar and Q bar, two vectors, are in same direction, what is its resultant? Their magnitude and direction. Now P bar and Q bar same direction, then theta equal to 0 degrees. If theta equal to 0, cos 0 equal to 1. So when we substitute here, what we will get? R equal to square root of P square plus Q square plus 2PQ. As cos 0 equal to 1, cos theta equal to 1, no need to substitute. Then it is looking like P plus Q whole square formula. Then R equal to square root of P plus Q whole square, then square root to cancel P plus Q. So when two vectors are in same direction, directly we can add for magnitude. Then for direction, alpha equal to, as theta equal to 0, sin 0 equal to 0, 0 by anything 0, so alpha equal to 0 degrees, angle is 0. When two vectors are in same direction, magnitude, sum of their individual magnitudes and angle between them is 0, so they are in same direction. Now if two vectors P bar and Q bar are in opposite direction, when two vectors are in opposite direction, angle is 180 degrees. Cos 180 equal to minus 1. Then we'll get R equal to P minus Q. Resultant equal to P minus Q. And then angle between them, alpha equal to either 0 or 180 degrees. Angle between them is 0 degrees or 180 degrees. Next, if two vectors P bar and Q bar are perpendicular to each other, then angle between them is 90 degrees. And we know cos 90 equal to 0. So resultant square root of P square plus Q square plus 2PQ cos theta becomes 0. P square plus Q square will be the remaining. This is the resultant magnitude of the vectors. And coming to the angle, alpha equal to tan inverse Q sin theta, sin 90 1, Q into 1 by P, Q by P plus Q cos theta becomes 0. So Q by P, tan inverse Q by. Next one, if two vectors P bar and Q bar, their magnitudes are equal, then resultant R equal to 2P cos theta by 2, and direction alpha equal to theta by 2. Magnitude, direction. It is very important topic. Thank you for watching. Please subscribe.